Hello and welcome to Selection with Sathi. Today we take a deep dive into async programming in Python. We'll cover the event loop architecture, async await mechanics, asyncio.gather and TaskGroup, async iterators and context managers, and how to use semaphores for rate limiting. The event loop is the heart of async Python. It's a single-threaded scheduler that runs many coroutines cooperatively. Unlike threads, there's no preemption. Coroutines yield control explicitly at every await. The loop checks which I/O operations are ready and resumes the waiting coroutines. Asyncio.run of main creates the loop and runs until your main coroutine completes. This cooperative model avoids most race conditions you'd face with threads. Async definite creates a coroutine function. Calling it doesn't run the code, it returns a coroutine object. The coroutine only runs when you await it or schedule it on the event loop. Await pauses the current coroutine and gives control back to the event loop. When the awaited operation completes, the loop resumes the coroutine. You can only use await inside an async definite, it's a syntax error otherwise. Asyncio.gather schedules multiple coroutines to run concurrently. It returns a list of results in the same order as the arguments. If any coroutine raises, Gather can optionally return exceptions instead of raising. Python 3.11 introduced TaskGroup for structured concurrency. With async with TaskGroup as TG, you create tasks with tg.create_task. If any task fails, TaskGroup cancels all remaining tasks, much safer than Gather. Async iterators support the async for syntax. An async iterable implements __iter__ returning self and ___ as a coroutine that returns the next value or raises stop async iteration. Async generators simplify this. Just use yield inside an async definite. This is perfect for streaming data. Async for message in WebSocket, async for row in database_cursor. Async Context Managers use async with for resource management. They implement __enter__ and __exit__, both of which are coroutines. This is essential when setup or cleanup involves I/O, like opening a database connection or starting an HTTP session. The @async context manager decorator from ContextLib works just like @context manager, but for async, use yield inside an async definite. Semaphores limit how many coroutines can access a resource simultaneously. Asyncio.Semaphore of n allows at most n coroutines to hold it at once. Use it with async with sem:, it acquires before entering and releases on exit. This is crucial for rate limiting. Don't hit an API with 1000 concurrent requests. Instead, use a semaphore of 10 or 20 to control concurrency.
Let's build an Async Web Scraper with aiohttp. The fetch function opens an async HTTP session and gets the page. In main, we create one session and use gather to fetch all URLs concurrently. 100 pages that take 1 second each. With gather, they all run at once. Total time is about 2 seconds instead of 100. That's a 50x speedup from async concurrency. The producer-consumer pattern with asyncio.Queue. Create a queue with an optional max size to apply back pressure. Producers await queue.put to add items. This blocks if the queue is full. Consumers await queue.get and call task_done when processing finishes. Run producers and consumers concurrently with gather. The queue handles all coordination, no manual locking needed. Regular file operations block the event loop, that's a problem. The aiofiles library wraps file I/O to be non-blocking. Async with aiofiles.open as f, then await f.e add or f.write. The syntax is identical to synchronous file handling. Under the hood, aiofiles uses a thread pool to avoid blocking. Always use aiofiles in async code to keep the event loop responsive. Python 3.11 introduced ExceptionGroup for concurrent error handling. When using TaskGroup, if multiple tasks fail, their exceptions are collected into an exception group. The except star syntax lets you catch specific exception types from the group. Except star value error catches only the value errors, while other exceptions continue to propagate. This is a huge improvement over Gather's all-or-nothing error handling.
Let's compare Asyncio and threading side by side. Asyncio uses cooperative scheduling, coroutines yield at await points. Threading uses preemptive scheduling, the OS switches threads at any time. Asyncio runs on a single thread, threading uses multiple threads. Race conditions are rare in Asyncio because there's no preemption. Asyncio scales to tens of thousands of concurrent tasks with very low memory. But neither helps with CPU-bound work. Asyncio blocks the loop, threads hit the GIL. Critical tips for Async Python. Use Asyncio for I/O-bound concurrency, it's lighter than threads. Never do CPU-heavy work inside an async function, it blocks the entire event loop. Use Semaphore to rate limit concurrent requests and avoid overwhelming servers. Prefer TaskGroup over Gather, it cancels on first failure for structured concurrency. Use specialized libraries, aiohttp for HTTP, aiofiles for files, async for PostgreSQL. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.